Okay, we are talking about relative extrema. We have the function here f of x equal to negative square root, and all into the square root is x squared minus 6x plus 13. Now, we're going to look at the graph here first before we do the math. As you can see here, the red dot right here, this is indicating where my maximum is occurring. And we're talking about relative extrema in this particular section here, so this is considered to be a relative max. And also keep in mind, it's also considered to be, since we're on the interval between negative infinity and positive infinity, it's considered to be an absolute maximum also. And I talked about that, tried to clear that up in a couple of videos back, but anyway, so, okay, well, let's get started with the math. So our function, I got it out of radical form, put it in exponential form, and now we're going to take the derivative. So I take the half, I bring it out front, rewrite everything in parentheses, subtracting 1 from the exponent, and we get negative half. Then we want to take the derivative of what's inside and chain it out. So the derivative of x squared is 2x, and the derivative of negative 6x is just negative 6. Now I'm going to go ahead and rewrite all of this. Take the half, multiply it by 2x, you just get x, and a half of 6 is 3. Okay, so as you can see here, we'd end up with x minus 3. I went ahead and left the negative out in the front here and didn't distribute it across. And because we have it in exponential form, I'm going to put it back into radical form. Because this is a negative up here, we want to take it back down into the denominator. And I just went ahead and wrote it back into radical form here. Alright, well, the next order of business is we're going to take the numerator, set it equal to 0, and solve for x. Well, it turns out that x is equal to 3. So that's going to be one of our critical numbers. And then we want to take the denominator, set it equal to 0, and there is no real solution. So there's not anything we can plug into this down here to actually get 0. So if you were to work this out, which I didn't work it out, we could go ahead and drop the radical sign, and we'd end up, if you can factor this, that would be great, set the factors equal to 0, but because there's no solution, we can't factor this. Or anyway, I shouldn't actually say that. But if you use the quadratic formula here, we wouldn't get any real solutions. We'd end up getting a negative under the square root if we were to set this equal to 0, just this piece right here, and use the quadratic formula. So we just end up with critical number is 3. And this should say critical number, not numbers, I don't know. Alright, well, went ahead and drew up this graph here. Put my critical number here as 3, did a test point 0, and another test point to the right here is 4. Okay, so we're going to take 0, plug it into the derivative now, and we end up with a positive number. And so that means we know that the function is increasing from everything to the left of 3. Now keep in mind, remember, you can choose any number you wish to the left of 3, but I choose 0 because 0 is an easy one to choose. Then we plug 4 in and we get a negative number, so we know that the function is decreasing. Now because we get a positive number to the left 3 and a negative to the right of 3, we know that this function must have a maximum occurring at 3. So I go ahead, take 3, plug it back into the original function, and we end up getting negative 2. So we know that there's a maximum occurring at 3, negative 2, and it's increasing from negative infinity at 3 and decreasing from 3 to infinity. Right, so by looking at the graph right here, you can kind of guess here. This doesn't quite look centered, but I did my best. But so here's 3 on the x-axis, and then we'd come straight across, and you can see here it's negative 2.